Continuing on, now vertical asymptote will be x equal negative 1/2. Horizontal asymptote, what dominates the top? That's 1/2. Y equal 1/2. 3. Y-intercept, that's simple, replace x by 0. I'll get 3 over 1, which is 3. And for x-intercept, a fraction equals 0 when the top equals 0. That happens at negative 3. So start with my asymptotes. X equal negative 1/2. Y equal 1/2. Anytime you have a horizontal asymptote that's not y equals 0, the graph will be a lot easier to get and you'll spend no time on it. 0, 3, and negative 3, 0. Left to right. A graph starts next to an asymptote and ends next to an asymptote. But a graph must cross through its intercept. So either I start up there or down there. The fact that this is here, do you think it's more likely that I start up there, cross the asymptote, or I start down here and go through the intercept? Even though sometimes you might be at the top, that's unlikely, so we're going to say it's and runs down. And how about the piece to the right? Do you see that I can't start on the bottom? Because if I start on the bottom, to reach that intercept, I need to cross the x-axis. I didn't get an x-intercept on that side. So the graph must start up there, go through that intercept, and terminate next to the asymptote. Like I said, if the horizontal asymptote is not y equals 0, the graph is very easy to get. How about this problem? Well, they already factored it for us. Vertical asymptotes, 2 of them. X equal 1 and negative 1/3. 2. Horizontal asymptote, what dominates the top? Remember, if I FOIL this, back from polynomials, isn't that a quadratic? And the denominator, if I FOIL this, the leading term, isn't that 3x squared? Those cancel out. Isn't that 1/3? That's how you find the horizontal asymptote. That's a calculus idea of a limit. This is the limit as x approaches infinity. 3. What is the y-intercept? Set x equal to 0. I'll get 1 times negative 2 over negative 1 times 1. Isn't that a positive 2? And 4, what is the x-intercept? A fraction equals 0 if the top equals 0. Well, that's at negative 1 and at 2. So I have 2 of them in this case. That happens sometimes. Start with the asymptotes. X equal 1 is a vertical asymptote, a dotted line that we can get very close to but never reach. Negative 1/3 is about right there. Oops, actually no, that's negative 2/3. About right there. Y equal 1/3, about right there. So these are the lines that are going to guide my graph. I have a 0, 2, negative 1, 0, and 2, 0. The piece to the left, do you think I'm going to start up here and cross that to reach? Or do you think I'm going to start down there and cross that? Well, it's more likely the bottom case. That's what we're going to assume. And you're going to terminate next to an asymptote. By the way, just to demonstrate, the graph is smooth and continuous, and the piece in between, I am going to elaborate on. I didn't forget about that. But the piece in between, do you think I'm going to start on the bottom, cross the x-axis to reach that? I didn't get an x-intercept there. It has to be there. Do you think this is going to come down or go up? Well, did you get an x-intercept there? If you didn't, then guess what? This is going to end next to an asymptote. There it is. The piece to the right, it's no big secret. I must start on the bottom, go through the intercept, and terminate next to the asymptote. I drew that so small, it's kind of hard to see, but there it is. Now, by the way, just to mention, this is the rectangular coordinates. The graph should be one smooth curve. One vertical asymptote will break this graph into two parts, right? So it'll really disconnect the graph and tilt it either up or down, there's no telling. Two vertical asymptotes, it'll take this graph and break it into two parts. So there are always more pieces, one more than the number of asymptotes, vertical asymptotes. How about this problem? Well, the same deal. That is x minus 2 into x plus 2 over x into x plus 1. One vertical asymptotes, I have two of them, x equals 0 and negative 1, 2. Horizontal asymptote, what dominates the top? X squared. How about the bottom? X squared. That is 1. 3. What is the y-intercept? Well, if you let x equal 0, you get undefined, right? Because negative 4 over 0, so none. And 4, what is the x-intercept? A fraction equals 0 when the top equals 0. There's two of them. So start with my asymptotes. I have 1 at 0. That's why there is no y-intercept. And negative 1. And y equal 1. So this graph has three pieces because there are two vertical asymptotes. No y-intercept, negative 2, 0, and 2, 0. The piece to the left by now, I should know how that looks. The piece to the right, I should know how that looks. The piece in between, not a clue. Either the graph is going to look like this, start next to an asymptote and end next to an asymptote, or it's going to start next to an asymptote and end next to an asymptote. How would I know that? I'm going to throw a value in there, a test point between negative 0 and negative 1. Say negative a half. Now, I do want to know if it's positive or negative. Well, if it's positive, it's up there. If it's negative, it's down there. Negative 1/2, you could use this or you could use this. Negative 1/2 minus 2 is negative. Negative 1/2 plus 1 plus 2 is positive. A negative 1/2 in there, that's a negative. Negative 1/2 plus 1 is positive. So that's a positive. That will have to be the top portion. And there's the graph. Like I said, if the horizontal asymptote is not y equals 0, sketching the graph doesn't take a lot of effort. How about this problem? Well, this is x plus 4 into x minus 1. This is x plus 2 squared. Alright, 1. Vertical asymptotes, well, there's only one of them. Multiplicity 2 doesn't mean anything. 2. Horizontal asymptote, what dominates the top? X squared over x squared. But those cancel out. 1 over 1 is 1. That's the horizontal asymptote. 3. What is the y-intercept? Replace x by 0. The only thing left is a negative 4 over 4, which is a negative 1. And 4, what is the x-intercept? Where does the top equal 0? At negative 4 or at 1? So, vertical asymptote, x equal negative 2. Horizontal asymptote, y equal 1. 0, negative 1. Negative 4, 0. And 1, 0. Well, the piece to the left obviously has to look like this. The piece to the right, do you think I'm going to come from up there? Or do you think I'm going to come from down here? Well, obviously from the bottom, because there are no x-intercepts there. I'm going to cross through that first intercept, second intercept, and terminate next to the asymptote. And I'm done. This problem, that's going to be, if I factor this, that's going to be x plus 3, x minus 2. So this is the third case, x plus 1. 1 vertical asymptote is x equal negative 1. 2, I'll get to in a minute. 3, the y-intercept. If I replace x by 0, I'll get negative 6 over 1, which is negative 6. 4, x-intercept. The top equals 0 when x equals 2 or negative 3. Now, to really clarify, a vertical asymptote is a vertical line. Horizontal asymptote is a horizontal line. An oblique line or a slant line is a line that's not vertical nor horizontal. Do you notice when I do the dominance, the top is dominated by x squared, the bottom by x? Anytime you have something like that, anytime you're not getting just an x in the denominator or the x is canceling out, you must use long or syntactic division to figure out what either an oblique asymptote or a slant asymptote. One of the two. Y equal, and it's going to be the quotient by x plus 1. So if I divide, x squared divided by x is x. X squared plus x, subtract. Cancel out. So my quotient is y equal x. The reason I ignore the remainder is written as negative 6 over x. As x approaches infinity, that zeroes out. So it's always, I'm going to go by oblique. Oblique asymptote is y equal the quotient anytime the degree of the top is greater than the bottom. So let me draw my asymptotes first. X equal negative 1. Y equal x. Zero, negative 6. 1, 2, 3, 4, 5, 6. 3, negative 3, 0. 2, 0. There's one vertical asymptote. The graph has two pieces. The piece to the left, either you start on the bottom or the top. If you start on the bottom, you're going to end next to the asymptote, but there's an intercept there. That indicates it can be that piece. Instead, it's going to be above, go through that intercept, and terminate next to the asymptote. The piece to the right, do you think I'm going to start on the bottom or the top? It has to be the bottom. And the reason it doesn't look like a curve because I really rescaled this. Otherwise, I have to go way down. Maybe I should have shrank the whole graph. That would have looked better. But you get the idea, I'm sure. If not, ask me during our discussion meeting. How about this graph? Well, again, it'll be a wise idea to factor. So 1. Vertical asymptotes, there are two of them, x equal plus or minus 3. 2. Oblique asymptote or slant asymptote, y equals, since the degree of the top is greater than the bottom, I'm going to use long division. X cubed divided by x squared is x. That is x cubed minus 9x. And that's a remainder. So it's y equal x. Again, it's just a coincidence. It's not going to always be y equal x. 3. The y-intercept. Set x equal to 0. Well, I notice if I put 0 there, I'll get 0 over negative 9, which is 0. And 4. The x-intercept. Where does the top equal 0? The top equals 0 when x equals 0, and this can never equal 0. So I have two asymptotes, 3 and negative 3. And a line that we make sure of that. If I take this, x cubed, that's x. Okay, a line y equal x. Now, I have an intercept through, again, 15% of the time you cross the horizontal asymptote. Well, let's see really quick. The piece to the left, either one of those or one of those, what do you think? Well, the fact there is no x-intercept there indicate it has to be the bottom piece. And the piece to the right, either you start on the bottom and end next to the asymptote or up there. Well, it has to be the top because there are no x-intercepts. The piece in between, I have to pick a test point because I'm not sure if the graph looks like this or like this. And I'm not sure it's going to continue down. Actually, I think it's going to continue down. If it goes up, it's going to cross the asymptote. We don't do that unless we have no choice. So I don't know which piece it has at the top. Well, I pick x equal -1 as a test point. A -1 in there, that's negative. -1 squared plus 2 is positive. -1 minus 3 is negative, and -1 plus 3 is positive. Two negatives will give a positive, so the graph looks something like this. And there it is.